Hi everybody. In this video, what I'm going to be doing is focusing on adding a reset feature to the counter that we've already been working with in the previous videos. So the goal here is to add a switch, basically reset it to 0 at any given time, just like a stopwatch, right? I want to be able to not only pause, which is what we added last time, but I want to be able to hit a different button and reset it to 0 so that I can start again, right? Even if the count's 8, even if the count's 4, it does not matter. So right now we have a circuit that's running 0 to 9. I can pause it by hitting the suspend button, but I want to be able to add now a button that resets it. Okay, so we have to know then for the 74LS93 what resets the circuit, right? And that would be the RO1 and RO2 inputs. And what we know is this: when we get a 1 into both of these at the same time, one at the same time of both of these, it will reset it no matter what's happening. It's an asynchronous input, which means it overrides. It does not have to wait for the clock. Don't care where the clock is. It's just going to happen automatically. Okay, so it's a very similar process to what we use for suspend. Okay, over here, I already have some stuff built off to the side. I'm just going to kind of drag it over into place. Maybe. Let's try that again. Okay. My good. Oh, trying to move stuff while it's circuit's running. Let's try this again. Here we go. All right. So I have then a switch set up with an AND gate. Okay. And it's going to be a similar process. What's going to happen now is right now the AND gate here is driving the reset of the circuit based on when the number 10 appears. When 10 appears, it resets it, which is why the 9 is the last number that we see up here. 10, instead of appearing, is a reset feature. But now what we're going to do is we're going to add a second method for resetting. And again, the common mistake that kids make is they want to come over here and they just want to connect a switch. Okay, you can't do that. You can't have two separate inputs going into one situation or one location on this chip. It just drives the thing bonkers. Okay, so instead, what we have to use is a logic gate. Okay, and in this case, I'm using an AND. There are other logic gates available. So one of the ways that we can drive this to happen is we can have this put a 1 out, or we can have this put a 1 out. Okay, and what we're going to do is say, all right, now let's look at this situation and what we might get out of it. Okay, if I have this as a 1, in other words, if this is connected to VCC, then what happens is the AND gate is the driving determining factor in what's going to come out of this 2-input AND gate. Okay, so if this is putting out a 0 like it does most of the time, then this is going to be a 0, which means it will not reset. But when this is putting out a 1, this is already a 1. We've locked it in with the switch. So when I have 1, 1, this will put out a 1 and it will reset. In other words, whenever I have this set up to be high, then the only thing that makes a difference is this 4-input AND gate. In other words, the condition being met over here. However, when I flip this to a 0, then no matter what happens here, I cannot get a 1 out of this. Well, that seems a little bit backwards, right? I mean, we need a 1 out of this in order to get the reset mechanism to occur correctly. So what we've decided then is this AND gate is not the correct type of AND gate that we want to use in order to drive the reset. We want it, now listen carefully to this next phrase. We want the AND gate to be able to reset the feature, reset the output, or we want the switch to be able to reset the feature. So think about this really quickly. Ready? Think about what I said. Either the AND gate can reset it or the switch can reset it. That's a big hint to the type of gate that we need. So I'm going to come up here. I'm going to replace this then, not with an AND gate, but with an OR gate. Either one of those should be able to drive what happens here. Okay, so different situation than what we talked about in the last video with suspend. So now let's look at it this way. Ready? Right now, this is down at a 0. If this is a 0, then it's not going to pass a signal through on its own. It's not going to pass the one that we need out on its own. It needs help. The help is going to have to come from this AND gate. Okay, when the 4-input AND most of the time puts out a 0, when it puts out a 1, that 1 will pass through and it will reset. In other words, with the switch down low, it acts normally. But when I flip this to a high signal, now we are getting a 1 out of this leg of the input. when this is a 1, we could care less what the AND gate is going to be. The 1 is going to hold in place up here with the reset, which therefore will drive the output to be a 0 no matter what. I think I did mess up. I have space running both of these, so I'm going to change this to be an R for reset, okay? And let's run the circuit and let's find out what goes on. So again, get this out of the way. I can suspend at any given time. That was the last video by hitting space. Notice it locks it into place. The 8 happens. I've just paused the clock using this AND gate. But now, when I hit R for reset, it brings it back to 0 no matter where it was. 1, 2, 3, 4, reset, back to 0. Because again, right now it's a 1, which makes this a 1, which makes both of these a 1, which activates the resets and holds it at a 0. So that's how you add a reset feature to a counter. You now have pause and reset, and hopefully an idea of why we chose those gates. And again, you're going to see in the curriculum different gates used. You're going to see NAND gates that show up for this, and they're going to talk a lot about NAND gates and why NAND gates are a better solution. That's all fine and dandy. My goal for you is to be able to have an idea of why you're using those gates, okay? So have an idea in mind, so that way whenever I give you something different than what they show you a picture of, you can build something that matches your requirements on your own.